Welcome to Polymorphism and with Go. We're going to be talking about function receivers and interfaces. So what is polymorphism? Basically, it's the idea that you have a grouping or a collection of objects that are heterogeneous, and you want to treat them in a homogeneous way. So you want to be able to call the same functionality on each of them and have them do the thing that's appropriate to their type. As an example, we're going to create a set of entities, and they're going to have the following three functions. The first one is getType, and this is going to return whatever the thing is: a tree, a house, a dog. The next one is display. We're going to give it a display area, whether it's memory, the monitor, whatever we're going to do, and we're going to say display, and it'll know what to do to make itself. And finally, we're going to set the color of the entity. So we can be able to say, hey, you're a green house, a brown tree, a purple dog, whatever, and go from there. We're going to give this set of functionality a name so we can conveniently refer to it later. In this case, we're going to give this set of functionality the name shape. And this defines an interface, the shape interface. So once we have this, we can go in and we can create a variable of this type, and then we can start calling these functions on it to make it do the things, and it do the things that we would expect something of that category or that classification to be able to do. So in this case, we're going to create a shape instance, our shape variable, and we're going to point it at a square instance. Now, square is already going to be predefined someplace as being a shape. And we can set its color and display it. And then we can do the same thing with a circle. And if we did it following the pseudo code snippet above here, we would see on our screen or in our display area someplace a representation of a red square and a blue circle, depending on how their display functions were implemented. So in Go, Go uses a Smalltalk style of polymorphism, of this, of the idea that I can create different blocks of functionality and give them the same name, but base it on the type of object that I'm targeting. Okay, and in this case, the receivers are the way we do that targeting. Traditional C++ style languages would take would have the definition of the object, and would have fields and methods inside the definition of the object, and those methods would be implemented for that particular type, and the object definition would say, hey, I implement this interface, and you would find those functions there. And then anybody who was wanting to use that object could use it by the interface ID rather than by the actual object definition. And that made it easier to group them together. Smalltalk was one of the first object-oriented languages that was defined. I think actually Lisp was the first one, but Smalltalk basically said, hey, the thing that I'm targeting for this functionality is going to define what the functionality does. So you would create a function for each type and each interface method to provide provide the functionality for that particular type. Go was not object-oriented, but it does use that style by using receivers and interfaces. And we'll see that in a moment when we write some code. So what are the two components of the language? Well, function receivers. This defines which block or which functional definition is executed when that name is applied to a particular type. And then we have an interface that defines the collection of functions that any object or any entity that wants to be one of those things must go and implement. Okay, so in this case, we would say, well, if you want a triangle, you have to have getName, and you have to have display, and you have to have setColor for your triangle type that you've defined. And that's basically polymorphism. And now we're going to go and create a simple application that does some simple polymorphic functionality, but we're going to show how you would implement this using the Go language And then you can take this and go and implement much more complex problems, obviously. But this is the idea behind this, is we're going to create a simple one as a guide for your further exploration and implementation. Stay tuned. So we're going to start off with a simple Go application. As you can see, it's just package main, format, main function, hello world. So this is a simple straight hello world application. And we're going to check to make sure that we didn't break anything by saying go run app.go, and we got hello world in there. Okay, so to keep you guys from suffering through me typing this and retyping it 4,000 times because I cannot type very well, I went ahead and created some snippets. So we're going to use the snippets to add our types, or just the different things that our problem domain knows about. So what we have is we have a person and a position. And we've kind of changed the style here. We were talking about shapes before, but now we're talking about, say, things within a business. We have people and we have positions that those people belong to. And we just want to know about those things. It's a real simple little thing, a little problem here. So a person has a first name and a last name, and a position has a title. So the next thing is we want to define the interface through which we want to talk to these objects or to these entities. So we'll go ahead and do that right here, and we're going to define our interface. In this case, we define an interface. Like in Go, it's pretty straightforward. You say type Namable, which is the name of the interface, and then you use the word interface, and then inside the curly braces, you list out all the different functions with their parameters and their return types that an instance that of a variable or an entity who wants to conform to that interface, like we spoke about before, needs to go and implement. And then we just created a collection of those. This could be from a, you could say this, I read this from a database or whatever, but this is just a simple slice of nameable things. So in this case, this is a slice of items that will specifically respond to the getName function. All right. So then we'll go down here and we'll go ahead and define those functions. So our implementation, we're using the receiver, function receiver syntax here. So we start with the word func, and you can see where we define the type of thing for which this particular instance of getName is implemented. In this case, it's a person. It has no input, it returns a string. And when we define this type for the receiver, we are now able to access the fields of whichever entity instance that we're dealing with by using the p variable there in this case. So we do just a simple return of a string that's formatted with first name and last name with a space between them. And then we have the same thing for the title, for the position object. So the position type, not object, because we're not object oriented, the position type has a getName function implementation, and it simply returns the title property. Now you can see where types being defined that were much more complex than these two, you would have a much broader interface defined for interacting with them, and they might do dramatically different things based on what they were and what the implementation was. One of the more interesting solution or problem domain is like bank accounts, where you have a base bank account, and then you have a bank account that that's a checking bank account that might have some overdraft protection, or you might have an investment bank account that does some tax deductible kind of things based on how much money interest is earning, that sort of thing. So these are some of those functional of the things that these are some of the things that you could do using this technique. Now finally, what we want to do is we need to go ahead and use these. So we'll go just delete that, and we'll say FRI, and we'll go down and do the main code. And as you can see here, we create a variable of the type namables. And that just says, hey, I'm a slice of namable objects. We then add two namable entities, a person and a position. Both of these, like we said before, implement the Namable interface. And now we iterate over that collection printing out the name of each entity in the collection, but we interface with it as if it were a nameable entity rather than a person and a position. And at the end, we see that we're able to interact with these heterogeneous objects or structures, types, in a homogeneous fashion. So we go down here to our terminal and we run our command again, and we now have name is Jane Doe, because that's how persons put out their name, and name is boss, which is how positions display their name or return their name, respond to the get name function. So from here you can see how you're able to create much more complex collections of entities and interact with them in a defined homogeneous way. And from here you can start building very, very complex applications, very, very complex entities, and solve really, really complex problem domains. I hope this was helpful. I hope you got something out of this. And leave a comment below if you have any questions. I'll try to answer it the best I can. Thank you.